So yes, I'm Remo van der Heiden, and I'm a PhD student at Utrecht University. And today I will be talking about work I did at Microsoft Research last year as a summer intern, which is about pre-alerting people for the handover situation. Here you see a vision from a car manufacturer of what the future could look like. And if you agree, I guess the future looks pretty bright, but as you might know, it will still take a few years before we see cars with such high level of autonomy on the road. But in the meantime, we will see that more and more driving tasks will be shifted from the driver to the car. So they will slowly transfer tasks from the driver to the computer. And also on the road, more and more cars have some kind of automated driving. For example, you might know the Tesla Model S, which has what we know as SAE Level 2 driving. So it can already stay in lanes, and it can also keep distance from the car in front of it. But as we go further, then we will see that cars in the future in SAE Level 3 will allow people to do other tasks while they are being driven. So the car will also monitor the environment. And that will, so as you see, that will allow people to read something, but it could also mean something else, like people will be able to get their smartphones out and do something on their smartphones. We thought of how can we support this distracted driver to still have a safe handover, so to still be able to grab the wheel on time and be safe. Because drivers, of course, need to be able to anticipate. They need to anticipate on what is coming. And previous studies show that 7 seconds is already, like a pre-warning 7 seconds up front is already much better than warning 5 seconds up front, or 0 seconds up front, as what it's now, I guess, in the Tesla Model S. But that might not be enough. So we propose pre-alert, which is much earlier, like 20 seconds. And we looked in a driving simulator study how that would go. And we used a driving simulator with STI Sim. And we tested participants. And we used an eye tracker, which you see in the bottom there. This is a movie, so I'll show that. And you will see that the car first drives autonomously, so the participant is not touching the wheel, and then at some point it will start warning, so that's the pre-warning. It will start for some situation which it cannot handle, and then you will see that there will be fog in the end, like at the end of the movie, and then the participant has to take over and drive through that fog.
Automation enabled. Automation disabled.
So that was one of our pre-alerts, which we called the increasing pulse. And I visualized it here, how it looked like. And then at the end you heard the automation disable. So this would be something which looked like, which sounds like when you rear park your car, for example. So increasing beeps. And we had another one, which is more like when you do not have your seatbelt on, for example. So it's 3 beeps, some silence, 3 beeps, some silence. and then 3 beeps again, and then automation disabled, and we call that the repeated burst. And we compared that with the situation where there was no pre-alert, so there was only automation disabled in the end. And people were aware which one they would get, so each, there were different conditions, and each condition they knew that which one they would get. So we had different events where people had to react on, or like where they were warned for. We had a stationary car parked at the side of the road. We had a dog crossing. We had a roadwork situation where there were cones on the side of the road where people had to drive through the cones. And we had the fog situation which we just saw, where people had to drive through a set of corners through the fog. Next to that, we had a task on the telephone to see how that works out when people are doing something else in their autonomous car. So we had 2 tasks. One task was a video transcription task, and another one was a calendar task where people had to add tasks to their imaginary calendar. So we were interested in how successful is the handover now. So we looked at how do people behave before, and we did that by looking at where people were looking, and we did look at when people when do people stop the task, and we looked at behavior after the handover, and last we looked at the feedback users gave us. So first the behavior before. So this is where a graph showing how many participants were looking at the road. So on the x-axis you see the time relative to the start of the pre-alert, and here on the y-axis you see the percentage of drivers looking at the road. So here's 0 and there is 100%. So, and here's the first part, so it's even before the pre-alert started, and you can see that that then people were aware that people who were aware that they would not get a pre-alert, they were sometimes glancing up to see if something was coming, we guess. So, and then if we go further, then we see that both the pre-alert ones pretty quickly go to almost 100%, and the no pre-alert condition still stays a bit behind. So, and from this point, some people would be looking up and then see that there was something coming, and then they, of course, they would also keep watching the road. But you can still see that they definitely, like, it's only less than 75% who looked at the road at the moment of handover. And then after the handover, you see that all of them are pretty much looking at the road. So we hope to see that people stop their phone task on time. So this is the no pre-alert condition. I'll show the other ones after that. So this is the time people continue after the onset of the pre-alert. And note that, of course, in the no pre-alert condition, there is no onset. But you see that they also continue pretty long, so about like 18 seconds. So, but if you go to the repeated burst, then you see that it's already much less. So they're about 10 seconds. And if you go to the increasing pulse, they stop their task even earlier. So if we go to the behavior after the handover, we can see here how people reduce their speed. So, for example, getting their foot off the accelerator pedal or braking. And you can see that both the pre-alert conditions, they start braking pretty immediately after the handover is here. And the no pre-alert condition stays a bit behind, so it's a little bit slower. So that would mean that it's a little bit like, it's just more dangerous because you have less time to react. So, and then we had the user feedback. So overall, users were generally very positive, but we heard that like so some found the increasing pulse alarm more distractive, and some found the increasing no. No, okay, so it was 50-50 divided over the type of pre-alert, and so that means that there might be personal preferences of which alarm they like best. So in the end, we can say that pre-alerts are pretty useful. For the behavior before, they look at the road earlier, and they disengage other tasks earlier, so they put their phone to the side and have a look around them, what's happening, so they can make their mental model of what's happening around them. So, and for the behavior after, they do make an earlier speed reduction, which also is safer, of course, and the user feedback is positive yet divided. So we have some implications and, of course, future work. So the implications for theory are that the driver needs time to recover from the distraction, and we saw that like we enable people to recover from the distraction by playing them this pre-warning. And then, of course, we are very much interested how this applies to a real car. How is this going to work in a real car? And then the implications for design. So definitely, we have seen that there's some like you have to balance the effectiveness and the annoyance, because if something is too annoying, like people are not going to like it. But still, like you want the alarm to be effective because you want them to stay safe. So this like is something like which can be optimized even more. And then we thought of like maybe in the future other work could search into the possibility of encoding information in the sound. So for example, if you, instead of a beep, have someone saying like, hey, there is a dog crossing, then you already know that, so you don't have to get that into your mental map. So I would like to thank our sponsors, which are the EU and the Dutch Ministry of Transportation, and I'm happy to take any questions.
Hi, I'm Gregory About from Georgia Tech. Could you go back to your slide that had the very first graph you had? Because there's something there I do not understand about the no alert situation.
Sorry for this.
Yeah, so why would the people that are in the no pre-alert decision have any reason to increase their attentiveness if they haven't gotten any alert? That looks very suspicious to me.
So yeah. We have had this, like in reviews, people were complaining about this as well. And so the reason is that, of course, there is an object on the road. So it's pretty similar to what would happen in the real world. So as you can also see in the beginning here, because they know they would not get a pre-alert, because they were driving in a car which they knew they would not get one, they probably glance up sometimes to see if something's coming. And that's pretty natural, I guess, because they don't want to crash into a dog.
Right. But the example the video gave, the cloud came pretty abruptly. You didn't really, in the video, you didn't really see that coming until it was almost there, as opposed to a car on the side of the road. But I guess you had a lot of different kind of situations.
Yeah.
Same thing about your next graph about why everyone slowed down. I mean, I drive a level 2 car, and when I take over, I sometimes go faster. So it seems to me it's all about the kind of slow situation that you presented them with.
Yes. So of course the situations we chose them as situations where we would expect people to slow down a bit. Like, of course, for a dog you would slow down. If there is fog and many corners, you would slow down. If there is cones and it's going to be a little bit smaller, then you would expect people to slow down. For the taking over the car, I guess people would also slow down, but yeah, it might be that you would indeed like speed up to take over that car, but like, yeah.
Hi, Heather Patterson, Intel Labs. Sorry if I missed it. How many trials did each driver experience, and did you have any false alarms in here? And if so, how did that affect performance over time?
So yeah, we were thinking about doing false alarms, and we actually did one, like the last one, where we did not put that in this paper. So people were doing how many trials? I guess 6. Yeah. Okay. And then there were 2 occurrences in each trial.
Okay.
Yeah.
Thanks.
Bastian Pfleging, LMU Munich. Can you go to slide 31? Basically the next graph.
Oh, that's 31.
That's a different one. So the timings, basically.
This one?
This one, yeah, and now, like all the other ones.
Yep.
So like the increasing pulse, did you test like different patterns over there? I mean, like different, like was it like linearly how you increased like the repeated sounds, or was there a different pattern? Because I guess that pretty much affects how the reaction time is. So if you get if the pulse increases quicker, people respond quicker probably. So did
we
you
asked
test
people
patterns?
for the before we did the study, we asked a few people
Okay.
about the preferences of the alerts, and that way we shaped the alerts a bit. And so as you can see in this graph, because I guess you're right, like the bursts, you can clearly see the bursts in the graph.
Mm-hmm.
So here's one burst, and then here's one burst, and then because people know that they have some time left before the actual handover is there, they look at the road and then they think like, oh, I still have some time. I'm going to finish my task a bit, and then like they make sure they are on time.
Yeah, because I think like if like for the increasing pulse, if like you increase very quickly, like it gets annoying to people, and so people react quicker probably. So that would be my assumption. And the second question, did you ask people like for the increasing pulse whether they found that this is confusing since like a similar pattern is used for, as you said, parking distance control?
We did not ask that. I can imagine that is a problem, but if everything goes automatically, then you don't need any real parking anymore. But so yes, I guess that's a problem. But
could be.
Yeah, we could solve that other ways, I guess.
Thanks for the presentation.
Okay.